graphs of functions and relations, which is found in section 5.3 of your Algebra 1 BJU textbook. So to begin, we are going to look at these ordered pairs, and we just want to look at the quadrant or the axis that contains each point. So for example, the coordinate or the point -4, 3, if we think about it, the -4 is the x or the horizontal. So you're -4 and then you're down 3 or you're up 3. So that would be in quadrant 2, because remember quadrant 1 is in the upper right and then it goes counterclockwise. So the point that we're looking at, -4, 3, would be in quadrant 2. So go ahead and try the others on your own and see if you can get them right. So 2, -5 is going to be over 2 and down 5, which would be in quadrant 4. 3, 6 is going to be over 3, up 6, which would be in quadrant 1. -1, -4 would be to the left 1 and then down 4, which was quadrant 3. And then 8, 0 would be over 8, but neither up or down. So that would be on the x-axis. And then 0, -5 would be neither left or right, but you are going to go down 5. So that's going to be on the y-axis. So the next question is, these points, do they form a function or not? So remember, in order for it to be a function, all the x values can only go to one y value. So, for example, I have -4, 3. So as long as I don't have a -4 that goes to any other y value, then that's okay for that one. And it's the same with every other x value as well. I have to make sure that each individual x value only goes to a certain y value. And as long as this is the case, then it is a function. So these 6 ordered pairs, they do form a function, yes. So let's take a look at this graph here. So this graph, let's say that this is a relationship between the height of a ball, which is the h, and the length of time it's been in the air, or t for time. So notice that I labeled my x-axis t for time, and I labeled my y-axis h for height. So t is the independent variable, right? So time is usually independent because time is going to move on its own, so it's independent. And the height, or the h, is the dependent variable. So that's how I knew which one do I make the x and which one do I make the y. Well, t, since it's independent, is going to be the x-axis, and h, since it's dependent, is going to be on the y-axis. So that's how I made the choice there. So since there are infinite number of points in this relation, the domain and range are going to be listed a little bit differently. So notice that the domain, or what the possible x values, are anything between 0 and 3. And the y values, or your h values, are anything in between 6 and 20. So how do we want to write that? So I don't want to write all the numbers between 0 and 3 that actually it's an infinite number of numbers. So instead, I'm going to write it as a set. I will say my domain, which I'll say is D, is equal to the set of t values. That's why I write the t. And then that vertical line there means such that t is in between 0 and 3. So notice how I have t in between 0 and 3. So let's take a look at something new. We're going to take a look at the concept of the vertical line test. The vertical line test, it can be used on a graph, and then when you use the vertical line test, it's going to determine whether that graph is a function or not. So what you're going to do is you're going to think about a vertical line that goes across a graph from left to right. And as long as only one point touches that vertical line at once, one point on the graph touches that vertical line, it's okay. But if there's ever a point where there are 2 coordinates on that vertical line, then it's no longer a function. So let's go ahead and practice using our vertical line test. You are going to have to take a look at the book. We're looking at example 1 on page 193. So let's take a look at example 1a. So the domain for this function, we can write it like this. The domain has 0, it has plus or minus 1, plus or minus 2, and plus or minus 3. Notice that my shorthand way of writing those, it's very much easier to write it that way, so please feel free to do that. So that's my domain for this graph. My range for this graph is 0, 0.5, 2, and 4.5. So looking at just the domain and range, it's not really easy to tell if this is a function now or not. Like if we were to list the ordered pairs, we would be able to see, but we can also look at the graph and tell. We can use our vertical line test, and we can say that yes, it is a function. There's no vertical line that intersects the graph at more than one point. So if we would take our vertical line and go left to right, all the coordinates only hit that vertical line once. So let's take example 1b. So this one, our domain has the values 0, plus or minus 1, plus or minus 2, and plus or minus 3. Our range has the values -2, -1, 0, 1, 2, 3, 4, and 5. So this is not a function because if you have a vertical line that goes through x equals -1, that vertical line x equals -1, you'll see that there are two coordinates or 2 points at that vertical line because that is -1, -2, and -1, 3. And so it is not a function. It does not pass the vertical line test. Let's look at example 1c. So this one, our domain are all the x values that are greater than 0, and our range is all real numbers because your y values continue to go up and down, so you have all real numbers for your y's. So is this a function? Does it pass the vertical line test? And it doesn't. In fact, it fails at several different points, like several different vertical lines has more than one coordinate on it, so it fails a lot. So example 1c is not a function. All right, let's take a look at the significance of equations. So equations are what we're going to use for our function rules. Our function rules tell us how to get our y values, right? It determines of the range, or the y values, that is associated with each member of the domain, or the x values. So let's take a look at this function. We have the ordered pairs x, y, such that y is equal to x plus 2. For the domain, x equals 1, 2, 3, and 4. So what you'll do is you will take your domain. Your first member of the domain is 1. You'll plug it into your function rule, the equation x plus 2, to get your y value, because 1 plus 2 is 3, so y equals 3, and then you have your ordered pair, 1, 3. You do that for each member of the domain that they have listed there. And now you have a set of ordered pairs that you can graph. And this is also going to be a function because no vertical line can be drawn through that passes more than one point. So on that example, we had x values given to us. They said x equals 1, 2, 3, and 4. What if they didn't specify what x could be? There was no limitation on the domain. Domain could be anything. Domain can be all real numbers. If that's the case, what we would do is we would plug in our own x values, and we can pick the same x values as they are already given us. We can already use those x values if we really want to, but because there's no specific domain, instead of just doing ordered pairs, you want to go ahead and draw a line, a connected line through those points, because the entire line actually satisfies the equation, because you can plug in any x value, not just 1 and 2, but 1.5 would give you an answer on that line or on that graph. So the coordinates of every point on the line satisfy the equation. So that's something that you need to know. If they don't specify a domain, if they specify a domain, you're just going to plot the points, Okay, if they don't specify a domain, or if they say domain is all real numbers, or domain is all the x's greater than 0, or they give you a domain where you have an infinite number of numbers, you want to go ahead and connect the ordered pairs with a line. Let's take a look at example 3. So this is a relation, and such that y equals 3, but you only have the x's between 1 and 5, but our domain has to be integers only. They cannot be rational numbers, so they can't be 1.5. They can only be 1, 2, 3, 4, and 5. So if that's the case, if they are just integers, you only have the 5 points. However, if you can be any number from 1 to 5, that means you can be rational numbers. You can be 1.1, 1.2, 1.3, 1.4, 1.111111, 1.1112. There's an infinite number of numbers. So you would have a segment or a connected line from 1, 3, the point 1, 3, to 5, 3. So it would be a line connecting those 2 points, or a segment connecting those 2 points. So it is a function because it actually makes a horizontal line, which you will learn anytime you have y equals a number. We call that a constant function. So y equals 3 is going to be a horizontal line at y equals 3. So you'll notice that that's going to be a pattern that you're going to want to recognize. Anytime you have y equals a number, you have a horizontal line at that number. All right, so let's go ahead and move on. Let's take a look at the function, or actually let's call it a relation until we know. The ordered pairs such that y equals plus or minus the square root of x for the domain 1, 4, and 9. So if you were to plug in 1, 4, or 9, the square root of 1 is 1 and -1. The square root of 4 is 2 and -2. And the square root of 9 is 3 and -3. So notice that each x value gave me 2 y values. So because of that, it's not going to be a function, but we can still graph the relation. It's just not a function. It fails the vertical line test. All right, so graphing functions, because functions are just a special type of relation, they're graphed using the same methods. You pick your domain, you either pick your domain or the domain's picked for you, and then you graph the range. So because you have to keep in mind what your domain is, if the domain's given to you, you plot points. If the domain's not given to you, there's no restriction on it, you need to connect those points. So let's take a look at example 5, where we have f of x equals -x squared. So they don't give us a domain, so we would actually want to pick our own numbers. I like to pick a couple of negatives, 0, and a couple of positive. So let's start with -2. So -2 squared is 4, and then -4 is -4. So I plot that. -1 goes to -1, 0 goes to 0, 1 goes to 1, and 1 goes to -1, I'm sorry, and then 2 goes to -4. So I get a graph that looks like that. Because my domain is all real numbers, they didn't specify my domain. If they don't specify my domain, then my domain is all real numbers. And then my range, as you can see from this graph, I don't have all real numbers for my range. In fact, I have a limitation on my y. The highest y value I get to is 0. I never get any higher than 0. So my range would be y is greater or equal to 0. Sorry, not greater than, less than. Whew, that's silly. All the numbers are less than or equal to 0, right? Because it can't go greater than 0, so that means it's less than 0. So notice how that I write it. I said all the y's such that, that's that vertical line right there, y is less than or equal to 0. All right, go ahead and try some problems on your own.